Now, before seeing how multi-level paging works, let's see why we need multi-level paging. Okay, in which scenario we go for multi-level paging? We don't go for multi-level paging always. Okay, only for some scenarios we go for multi-level paging. Before seeing what is multi-level paging, let's see when we should go for multi-level paging. Let's see this. Let us assume size of a single page equal to 16 bytes. If size of a page is 16 bytes, then obviously size of a frame will also be 16 bytes, right? So size of a single frame is 16 bytes. Also process P1 will also be divided into 16 byte blocks. 16 byte blocks, and we say them as pages. And what we do, see, this assume that this is process P1. Okay, now what we do is we take the page and then we'll place it in the frame, right? We'll take the page and then we'll place it in the frame. Now what we are actually doing is we are actually placing the various pages in non-contiguous memory frames. Now we maintain something called as page table, which means for every page we are going to maintain an entry in the page table of process P1. We are going to maintain an entry for the page table of process P1, and within the entry we have the frame number in which the page is actually present, so that we will be able to get the exact frame in which the corresponding page will be present. That is what we have seen so far. Now let's assume that size of page table entry equal to 4 bytes, which means size of a single page is 16 bytes and size of a single page table entry is 4 bytes. Number of page table entries of process P1 is 5, which means since we have 5 pages for process P1, 1, 2, 3, 4, 5. Since we have 5 pages for process P1, then obviously number of entries in the page table of P1 will also be 5. See, don't take this table, okay? I'm just telling you, don't take this table. Assume that there are exactly 5 entries in the page table of process P1. Okay, forget about this diagram. I'm saying that number of page table entries of process P1 will be equal to 5, because we have 5 pages for process P1. So for every page we maintain a entry in the page table. Now what is the total size of page table? Size of page table is nothing but number of page table entries of process P1 into size of a single entry, right? Number of page table entries we have into size of a single entry will give us the total size of the page table. Now the total size of page table is nothing but 4 into 5, which is nothing but 20 bytes. So size of page table of process P1 equal to 20 bytes. Now I have already told that even the page table of a process will also be placed in the frame of RAM, right? Even the page table of process will be placed in the frame of RAM. But one thing you can understand is we have already seen that size of a page or frame equal to 16 bytes. Now size of page table equal to 20 bytes. Now in case if it is 16 bytes or less than 16 bytes, what I will be doing is I will be placing the complete page table over here, right? Complete page table over here. Page table of P1. In case if the size of page table is 16 bytes or less than 16 bytes. See, in case if it is 16 bytes, what I will do is I will take the complete page table and then I will place it here. That is fine. Let us assume the size of page table is 15 bytes. In that case, what will I do? I will take the page 15 bytes, page table whose size of 15 bytes, I will place it here and then I will leave 1 byte of space as it is. Okay, the 1 byte of space will be wasted. That is what we mean by internal fragmentation, right? Now, what if the size of page table is greater than the size of frame? In case if the size of page table is less than the size of the frame, internal fragmentation. In case the size of the page table is equal to size of the frame, then no issues. In case the size of the page table is greater than the size of the frame, then there comes something called as multi-level paging. Okay, that is the exact scenario where we go for multi-level paging. So what we do here is, since page table size is 20 bytes, let us assume this frame and this frame is what our CPU has chosen to place process P1. Okay, so page table of 16 bytes of page table of process P1 is placed here, and 4 bytes of process P1 is page table of P1 is placed here. Here we will have remaining 12 bytes. This is 4 bytes and this is 12 bytes, right? This 12 bytes of space will be wasted. We can't do anything else. As long as this frame is placed, page is placed here, we can't do anything else. So clearly there is internal fragmentation problem. So what I have done is I have placed the 16 bytes over here and 4 bytes over here. Now comes a problem. The page table is actually placed in non-contiguous allocation, right? Are you understanding it? See, whenever I place the complete page table over here, the entries of page table is actually placed in contiguous allocation. So what we did is we used simple addition in order to index into the page table. Okay, we use simple addition in order to index into the page table because the page table entries are placed in contiguous allocation. But here the page table is itself placed in non-contiguous allocation. This is the exact scenario we go for something called as multi-level paging. I know it is a bit difficult what I mean by exactly simple addition and all this. We'll see that anyway. Okay, we'll see that in the next video. What is meant by multi-level paging and all this. Now, only thing I want you to understand from this video is when we use multi-level paging. We use multi-level paging only when size of page table is greater than the size of a frame. Okay, only in that case we go for multi-level paging. Fine.